Guys, so we are back to our lesson on arithmetic sequences and series. This is your pod for today, so go ahead and get this pod down. Pause this video to make sure you yourself try it. And then when you're ready to check the answer, press play. Okay, so I really do want you guys to actually try this on your own. And then when you're ready to see the answer, press play. So if you guys get to try and you're pressing play to see how well you did, knowing that this is an arithmetic sequence, you know your first term is 3k plus 1, your second term is k, and your third term is negative 3. And in order for a sequence to be arithmetic, you know that your second term minus the first term will give you your common difference, and that should be the same across the board. So when you subtract your second term from your first term, it should be the same number you get if you were to subtract your third term from your second term. So you use that type of equation to basically set up an equation to solve this. So you should have had k minus 3k plus 1 is equal to negative 3 minus k. Okay, if you're following this set format formula here, okay? And then it's nothing but a linear equation which you solve, so you'll have k minus 3k minus 1. Make sure that you carry that negative over, equals negative 3 minus k. And then combining like terms, getting your variables all to one side, okay? To keep my variable positive, I'm going to add 2k to the other side. And then I'm going to add 3 to the other side. So I find out that k is equal to 2. Okay? And hopefully you guys got that. If you wanted to check, you could easily just plug in to see exactly what would be the terms of the sequence. So if you plug in 2, then you end up with 7. And then you'll end up with 2, and then negative 3 as the first 3 terms of this arithmetic sequence. And as you can see, each is decreasing by 5. So you have a common difference of a negative 5. Okay? But to your notes, we're going to kind of pick up from where we left off. The notes were guided last week, so go ahead and pull those out. If you had any questions on the last homework, go ahead and save that to next class, because this lesson will be addressing any of the remainder arithmetic sequences and series content that we didn't get a chance to get to on Friday. And so so basically, if you have any questions about anything, hopefully after this lesson, the rest of the homework makes sense, okay? And that's what you'll be doing after you watch this video. Okay, so finishing up, we were talking about arithmetic sequences. Now we're talking about the series. The series basically means sum. Okay, it's the sum of the first n terms of an arithmetic sequence, and it's denoted by this notation of S sub n. Okay, so whenever you see that, you're basically adding your first term to your second term to your third term, your fourth term, all the way up to a certain particular term in the sequence, hence the U sub n. And to go ahead and find that, it's going to be S sub n equals n over 2 times 2 times your first term plus n minus 1 times d. It could also be represented as n over 2 and then your first term plus your last term, okay? You do not have to use both. You choose pretty much one or the other, which one to choose. Now, depending on what type of sequence you may get, sometimes it's a lot easier to use this first formula. Other times it could be a lot easier to use the second formula. Hopefully you kind of notice when you might use one over the other. This one here is if you know your first term, you're able to figure out your common difference, and maybe you know your number of terms, you know you can use the first one. This one here, you know your first one and your last one, and then that, you know, this one might be a little bit easier to use. You do not have to memorize these. These are in your reference booklet. Okay? So we're going to look at 2 examples, and you're going to try one on your own. This one says the first 4 terms of an arithmetic sequence are 5, 8, 11, and 14. We're going to calculate the sum of the first 80 terms. Okay, so we know that if we're calculating the sum of the first 80 terms, we know n is 80. And in this case, hopefully you recognize that the first formula would actually be a little bit easier to use to solve for this, because 1, we know our number of terms, which is 80. So it's going to be n divided by 2. All right. We also know our first term, so it's going to be 2 times our first term plus n, which is 80, minus 1 times d. And looking here, we can see that our common difference is 3. Okay, so we have 80 over 2 times 2 times 5 plus 80 minus 1 times 3. Okay, so doing a little bit of math, we already know that 80 divided by 2 is 40. And at this point, you really can kind of do it whichever way you prefer. You just want to make sure that you're doing your math correctly, order of operations and things like that. Okay, and so we have 247 times 40, and so then our answer is going to be 9,480. And since that's an exact number, we don't really have to worry about rounding to 3 significant figures. And honestly, guys, this is a lot easier than trying to sit there and actually, figure out what are all 80 terms and then just add them all together. So, use the formula. That's it. Let's look at the next one. It says find the sum of the series. So we have negative 3, 1, 5, 9, ... 81. Now this was different from the other one because we do not know our number of terms, do we? No, we don't. We only know that our last term is 81, our first term is negative 3. Our common difference, we definitely can figure out that's nothing but plus 4. But the only issue is we do not know, what 81 is. And we're not going to sit here and just add 4, to the previous term to figure out exactly what term it is, because it's going to take us a long time to do that. So instead of sitting there and trying to figure out, okay, well, 9 plus 4 and then 13 plus 4 and so on and so forth, what we can do is we can use that very first formula that we learned about on Friday to figure out, okay, well, what term is 81? Okay, and this is what we did, like I said last week. We set up the equation to find the value of n. Okay, we know that d is 4 because we're adding 4 to the previous term. We know our first term. We know our nth term is 81. Okay, and so I believe everyone did it where it was you add 3 to the other side, and then you'll have n minus 1 times 4. Divide both sides by 4. That's 21. And last step you have to do is add 1. So 81 is our 22nd term, okay? Now to figure out the sum of the first 22 terms, we can use our formula again. Now we know that n is 22, it's going to be 22 over 2. And what we can actually do is we can actually use the second formula here, which is u1 plus u sub n. And I mean, we could use the other formula. All right, but since we do know that our first term is negative 3 and we know our 22nd term is 81, hey, why not? So we'll have 11 times 78, and 11 times 78 is 858. Okay? And what I went ahead and did was actually show how using the other formula still gets you the same answer. You just have a little bit more to plug in, but you still get the same thing, whether you do it using the second formula or the first formula. Okay? So I want you guys to do is I want you guys to give this one a try. I want you to pause this video, like literally, I want you to pause this video. I want you to get down this example, which is not a part of your notes, so you are going to pull out a separate sheet of paper to put this on. And then I want you guys to give this a try, and when you're ready to check to see how well you did, press play. Okay, so go ahead and pause this video right now. If you're stuck, here's a hint, okay? You know that the sum has to exceed 450, so that means it has to be greater. So using this right here, knowing that the sum has to be greater than 450, why don't you use one of the sum formulas and then set it greater than 450 and solve it like a regular inequality. All right, hopefully you used this formula here because, again, you do not know what your last term is, so the first formula is going to have to be the one that you use. And since you do not know how many terms you have, n is your variable. That is what you're trying to solve, okay? So if you were stuck again, here's another hint. Hopefully you can go ahead and solve it from here, all right? So go ahead and pause this video, and then press play when you're ready to see the rest. All right, so going ahead and multiplying both sides by 2 and doing a little bit of math here. I have n times 22 plus, And I'm going to go ahead and I'm going to distribute that 5, okay, just to make it a little bit easier for me. I know some of you guys don't, you don't really do that. You rather do, a different way, but hey, I'm going to do it this way, okay? And then I shall have 22n. Okay. And of course, this happens as I'm recording. I realize that I end up putting a problem that you have to solve using quadratic, and we haven't covered quadratics yet. So guys, I do apologize here. When you end up combining your like terms, you'll end up with a quadratic equation that you'll need to use quadratic formula or factoring to go ahead and solve to find your values of n. So I'm actually going to stop this example right here. Not going to continue because again we haven't covered quadratics, and even though you might have did quadratics in your previous class, I won't be expecting you to know how to do this particular type of problem just at this very moment. Later, once we cover quadratics, we might revisit it, okay? So I do apologize for this. We're going to go ahead and move forward. Applications. These are your word problems relating to arithmetic sequences and series, okay? And word problems are not as bad as some students may think they are. Really, you just have to figure out, okay, what's the question asking you to do? What process do you need to use to solve it? And you just got to do it, okay? So this first one says the soccer stadium has 25 sections of seating. Each section has 44 rows of seats with 22 seats in the first row, 23 seats in the second row, 24 seats in the third row, and so on. How many seats are there in row 44 of one section, okay? So starting with A, we already know that our first term is 22 because we know that there are 22 seats in the first row, okay? We also know that our common difference is 1 because each row is increasing by one extra seat, okay? And we also know n. We know that n is going to be 44 because we want to know how many seats are in the 44th row. So we can go ahead and use that very first formula that we did last Friday of u sub n equals u1 plus n minus 1 times d. Okay, so then we'll figure out that our number of seats in the 44th row are going to be 22 plus 43, which is 65. So we know there's 65 seats in the 44th row. Okay, not too bad. Now let's look at B. Now we're trying to figure out how many seats are in each section. Okay, so this is actually asking for what's the sum of all 44 rows. That's what it's asking you to find. Okay, because each section has 44 rows in it, so you're trying to find the sum in each section, or the number of seats in each section. So n is 44. We're going to divide that by 2. And since we know how many seats are in the first row, and we also know how many seats are in our last row, let's go ahead and let's use that formula for, when you know the first term and the last term, just to make it a little bit easy on ourselves. So we know there's going to be 22 times 87, and 22 times 87 is 1,914. Okay, so we know that that's how many seats are in each section. Okay, hopefully this is not too bad. Okay, now we need to determine the whole stadium. Well, at this point, hopefully you can kind of realize that, okay, if there are 25 sections and there are 1,914 seats in each section, all you have to do is multiply 25 times 1914 to figure out the total number of seats that are in the entire stadium, and there's going to be 47,850 seats total. Hopefully that didn't confuse anybody. So let's recap. Because there were 44 seats in each row, all right, we knew in our first term was 22 seats in the first row. We knew, and it was increasing by 1. We knew our common difference was 1. And then we were able to figure out how many seats were in the 44th row by doing the very first formula. Okay? Each section basically wanted us to figure out how many seats were there total in each section. So that means adding up all the rows together. 23 plus 22 plus 23 plus 24, so on and so forth, using the shortcut way. We figured out there was 1,914 seats in each section, and since there are 25 sections in the entire stadium, we were able to determine that there were 47,850 seats in the stadium. Let's look at another example. A bricklayer builds a triangular wall with layers of bricks as shown. If the bricklayer uses 171 bricks, how many layers did he build? Okay, so this 171 bricks represents what? The total amount of bricks that he uses for this figure. Now, the one thing that we know is that there is one brick on the very top, there are 2 bricks on the second, 3 bricks on the third, 4 bricks on the fourth, which means that each row is increasing by 1. So our common difference is 1. Our very first term is 1. Our very first term is 1. And we also know that u sub n is equal to 171. Okay? So let's figure out how many bricks how many layers he built, which represents n. N represents the number of layers. So it's going to be 171 equals our first term plus n minus 1 times b. Okay? So we're going to have a 170 equals n minus 1 times 1. Well, we all know that that's just, 1. So 170 equals n minus 1. So we found out that he builds 171, 171 rows. Or layers. I know you're probably like, well, that was easy to do, Ms. Anderson. Well, I get that, but sometimes the problems might not be as straightforward, but you still need to make sure you go through the processes to help you answer that one, okay? Now this one, I want you guys to pause the video and actually want you guys to figure this one out, okay? And then when you're ready, press play so you guys can see the answer, all right? And I do not believe that this one involves quadratics. I went ahead and double check that, but you do gotta be careful. Just one little thing. Let's see who recognizes it, okay? So pause the video right now, get down this example, and then I want to see, I want you guys to try it, and hopefully you'll be able to get it before you actually see the final answer. Here's your first hint. Hopefully you recognize that he walked for 10 kilometers in the first week, and thereafter he walks an additional 500 meters. Go ahead and convert everything to the same unit. It makes things easier. Remember, King Henry died while drinking chocolate milk. Kilometers is 3 units away from meters, so you have to move it over 3 decimal places. So 10 kilometers equals 10,000 meters. That should help you figure out how far does he walk in the very last week and how far he's walking total. Quick hint, how many weeks are there in a year? 52. So hopefully you set up part A like so. Since you're looking for how many meters he walked in the first week, you did 10,000 plus 52 minus 1 times 500. And hopefully you got 35,500 meters is how much he walked in that last week. So then in total, you can figure out that in total for the entire year or for the entire 52 weeks, okay, you do 52 divided by 2. You do the first amount, which was 10,000, and you add that to the last week, and then you do the math. And hopefully find out that he walks basically 1,000,000 meters. God, that's a long time. Or a long distance that he's walking. Let's convert that back to kilometers. Remember, you got to bring it over. So then it's going to be 1,183 kilometers that he walks in a year. Okay? So hopefully you were able to follow along with Arithmetic Series and also with the applications. I want you guys right now, I want you to finish up the homework that was given out to you on Friday. And then make sure whatever questions you have, you bring that with you on Thursday. All right? Email me if you have any questions as well, or message me on Schoology.